All right, good morning, everyone. Let's go ahead and get started. Welcome to this webinar entitled SolidWorks and the Manufacturing Workflow, brought to you by Desai Solutions. I'm Jared Spaniel, an applications engineer out of our Fresno, California office. Today we're going to be looking at the SolidWorks suite of products and how they can work in unison to get your designs ready for production and how it relates to manufacturing. So a brief overview of what I want to go over today. I'm going to convey my goals, what I want to accomplish with the webinar, and then I'm going to take a look at a high-level look at our suite of products and what each product has to offer. Then we'll look at a workflow and how it kind of pertains to manufacturing, and then a demo of a few of these products and how they can work together. So my goals today are to showcase a variety of SolidWorks products and then hopefully align those products with a manufacturing workflow. So I have a quick poll question just to kind of get everyone warmed up, get started, and see, what my audience is and who's out there kind of listening. So the question is, what is your level of familiarity with the SolidWorks suite of products? You've used 4 or more additional products to the core SolidWorks. You've used 2 or more additional SolidWorks products. You're only a core SolidWorks user, or maybe you haven't used any of these products. I'm going to go ahead and launch this poll. If everyone just take a quick second and throw an answer up there for me, I'd appreciate it. Just so I can see what your guys' experiences out there are. And I'll wait a minute or so for this. All right, it looks like mostly everyone's voted, so I'm going to go ahead and close the poll here. So kind of interesting to see, about 50% of you are only a core SolidWorks user, and then I've got a pretty good distribution between 2 and 4 products for the rest of it. So 30% have used 2 or more, and 20% have used 4 or more, which, wow, that's pretty cool. 20% of you guys have used 4 or more products. No one is new to SolidWorks, so that's good to know. So this is kind of a really good distribution to show you guys some more products and what's out there and what you can actually do with everything we have to offer. So that segues me into this next slide, which is our SolidWorks products and how everything kind of ties together. So of course, down in the bottom left corner there, we have our mechanical design software, which I'm sure everyone out there looks like they're very familiar with. That's just our SolidWorks core, our 3D modeling software. Your part, your assembly, your drawing files, probably the most common thing that everyone uses. And then of course, we have our electrical design products. So if you don't know, we have a couple products in this offering, which include our 2D schematic tool, where you can build schematics that translate over into an electrical 3D package, which can lay out your wiring and your all your components and how everything kind of fits together within that. And then another product that falls under this category is the SolidWorks PCB product, where you can design PCB boards, layouts, traces, all these types of things within our PCB design tool. Then we have our data management, which is our PDM, our product data management tool, which runs through Windows Explorer, which is a pretty key tool if you have a large or a small organization to manage all your data, keeping track of your component part history, revisions. Can do so many things. It's got a nice database search engine. I'm going to show a little bit about PDM coming up here in a minute. Then we have our simulation tools, which are quite a wide variety of tools there. Most commonly, we have our FEA tool, which is like our static simulations, linear and nonlinear. There's quite a few other niche simulations mixed in there, like thermal, fatigue, drop testing, all these types of things. And then diving deeper into the simulation, we have our flow simulation, which can simulate fluid flow, airflow, multiple things like that in an external or internal environment. Then we have our plastics injection molding simulation software, which of course simulates how plastic materials flow into a part or a mold. Then we have our communication, our technical communication products, which are a SolidWorks inspection, which I'm going to show here today as well, which can automatically balloon drawings, do a lot of things with CMM, data importing, inspecting your components to make sure you actually got what you requested in your drawings, right? And then we have SolidWorks Composer along with that, where you can build manuals, technical work instructions, animations to show how components go together, videos, all these types of things within that software to communicate how you want things to be assembled, used, put together, right? So a brief high-level overview of all those products. We've got quite a lot of things in that suite of products that can appeal to individual needs or as a whole can work together to accomplish one goal. And that's kind of what I'm trying to convey today is as a whole, everything working in unison, right? So we all know a development process or a manufacturing design process, I would hope. What SolidWorks proposes is that, just like any other project, you identify your user needs, you start your preliminary project specs, what you're actually going to design to, and then we want really everything to run in parallel. This is also, of course, known as concurrent engineering. So we want you to use all these tools concurrently to get to your production phase much faster and hopefully make better business decisions and shorten your overall cycle, in turn saving you money, right? We want the engineers to invest the needed time to do their job, but in a more efficient manner. And this hopefully will at least give you an idea of the right tools that they need to have the information to make these decisions. So in this case, my example here for my workflow shows, my product design, which is of course the SolidWorks 3D CAD. We manage our data with PDM. We run some simulations, and then we communicate our data somehow with one or multiple of these SolidWorks products. Now, the manufacturing process using our SolidWorks products might look something like this, right? This is kind of a little workflow example I put together. We have our 3D CAD here to design your products. Then we need to know that our products are going to actually work, that they will do what we say they're going to do. They're not going to fail in the field. They're going to be able to go for so many cycles. So we run some simulations. We check things out. We make sure everything's good to go. Then we communicate our design somehow. We make sure that we have inspection. Our parts are properly quality assuranced. They have correct inspection dimensions. The key dimensions are noted. That's what we can all do with our SolidWorks inspection package. Then we have maybe MBD in here, which is our model-based definition, where we can convey some product manufacturing information within the 3D realm. Then we utilize Visualize to showcase our designs and highlight how good everything can really look with this awesome rendering tool in a really fast way. And then, of course, at the top here, everything is controlled within our PDM software. So all our designs, all our technical communication is housed within PDM here. Everything is in one location we can find, and of course that houses or can store multiple file types like images, videos, Word docs, PowerPoints, all the associated technical documentation you need for your product. Can store the Visualize files, all the SolidWorks files, multiple different types of things can all be housed in that one PDM vault. We're going to look at that a little bit more in a second here. But let's take a look at this cool product I found, this mountain scooter. So this is a design and development of an off-road scooter here that can go pretty much anywhere. So I'm kind of going to use this and some of the related components to show a few things within this workflow that I've just explained here. So where do you start, right? We've got the model complete. Now what? So I'm assuming our design is done at this stage. Everything's mocked up in 3D CAD. We're good to go here. We're going to look at our data management tool. This is our SolidWorks PDM, standard or professional. And of course, if you don't already know, they've really done a great thing. They've included SolidWorks PDM standard within the purchase of SolidWorks professional or premium. So you may even already have standard and not know it. You just need to have it activated. And then we can definitely help you get that set up, get that implemented, migrate your data, whatever you need to do to get that up and running, right? So just contact us if you need more information on that. But let's jump in and take a look at PDM a little bit, just very quickly. So I'm kind of going to do a high level on a bunch of multiple products, just to kind of show you how things might work. So this is PDM essentially, right? Everything runs within SolidWorks Windows Explorer. I have a couple project folders in here, and this is all housed on my local C drive. I can access my folders. So if I jump into my design data, I have components and different sizes. I can look at a few things in here. So what I really like about PDM is if you highlight a component, you get this nice eDrawings preview window down here where you can rotate and zoom. Very similar controls to how you use SolidWorks, but within eDrawings, an eDrawings powered viewer. And what this basically does is it allows you to look at this component and make sure that you're actually getting the component that you wanted to look at before you spend time, opening it, especially if you have a large assembly or something like that. You don't want to wait all this time to open it when you can just check it in here and make sure that it's the right component that you're looking for. You can have customizable data cards in here that show various information. In this case, gives me my current state. I'm editing this component still, so within my workflow, I can make changes. I haven't submitted it for approval. Maybe it gives me a comment in here about the last version. Lets me know if it's a purchased or built part, what the vendor is, the part number, who created it, when, the description. You can customize these with various things like your company logo. You can change the fields, a variety of customizing options in here to make it fit your needs. Then it tells me, the version that I have. Maybe I have 10 versions. What version do I have locally? Do I need to get the latest version? Gives me my bill of materials directly in here. What is making up this component? Tells me where it's used, in what assembly, where it's located, and all these types of information. Also tells me who it's checked out by up in the viewing window here. And you can customize all these headers and stuff like that. And then if I jump back to my main folder here, you can see I can store some documentation within here. In this case, I have a PDF. I have an image that I created within Visualize to showcase my product. I have my product specifications as a Word document. I have a Visualize project file that I was working on for this component. So all these things are housed in my documentation folder, making things really easy within PDM. The other really cool thing about PDM, right, is you can access PDM through your SolidWorks window. So you don't have to jump into Windows Explorer for this. You can actually utilize this PDM add-in and get a lot of the same or more of the functionality in SolidWorks that you can within Windows Explorer. So if I open this up, you can see in here I have my top level. I have all my components that go along with it. Lets me know who it's checked out by. In this case, I'm the admin, so I have a few files checked out as admin. Gives me all the status of my components. So in this case, I have a newer local file. I can do some things in here like get the latest version. I can get an older version. So in this case, I have version 2 because I made some changes. Maybe I want to step back to version 1, or if I have multiple versions in here, I can look and see what's changed in version 3 if I have version 10. I can check my files in and out directly from this window. I can look at the properties. I can see where it's located in Windows Explorer. I even get a nice little preview here of the component. So if I click down through my tree here, it's showing me each and every component in here and giving me some information, some feedback on this component, similar to what I had already discussed. So that's kind of a brief high-level overview of PDM, right? A very useful tool to manage all that data and communicate, make sure you don't have multiple people working on the same files, making different changes. You can track the history, so if they do make a change, you can see what they actually changed and why. All these things are heavily controlled within PDM. So now once we've got our parts designed, we've got our data managed, everything's set up, right? What are we going to do next? We need to test our parts virtually and save some prototyping costs, right? We don't want to manufacture some parts without knowing that they're actually going to do what we say they're going to do. They're going to hold up to our needs and, you know, meet the stresses or meet the displacement or the factor of safety that we spec'd out for this. So we want to design our parts for optimization, save material costs in the long run, and verify the part meets the end user needs. And this is all done within simulation. So let's take a look at a little quick simulation example here. So if I take a look at this part, now I've already set this up and ran the simulation. This is one of the truck assemblies for the component. I wanted to make sure that it was going to be able to support the weight of, in this case, I just spec'd out a 300-pound person being able to be supported by this one truck, right? So I have some forces here and some fixed constraints. What I've done here is I've ran an analysis and I've got a stress feedback here where it's letting me know where I have some high stress concentrations in these corner areas. And you'll see that my max stress here is, you know, about 48 megapascals. Well, the first thing you can do to check this out is verify that you're actually not exceeding your yield strength, right? So in this case, I'm using a 1060 alloy here. So if I take a look at this material, 1060 alloy, I know my yield strength is about 27 megapascals. So I got a problem here, right? I'm 48 and 27, I've exceeded my yield strength. If I look at my factor of safety, my minimum factor of safety is very low. So I know right away that just by looking at my design and what I've spec'd that I've got a pretty high chance that this is not gonna, you know, meet my needs, right? So this lets me know right off the bat that I need to do something here. I can do multiple things to fix this problem. I can thicken my part. I can, you know, change the design. I can maybe get rid of these slots or change the geometry of how the slots are, multiple things. Or I can just go in here and maybe I need to change a material. So instead of an aluminum, maybe I want to use a 1020 steel. So I'll go ahead and just apply a 1020 steel material to these. Very simply, I change my material on those parts, and then I would just go ahead and rerun my study. SolidWorks recalculates that, and then even lets me know the yield strength since I'm using all the same materials now. 351 megapascals, and I know my max still stayed the same due to the force over area equation, so I only use 48 megapascals. So I know that now that I've changed my material, this part's going to hold up no problem. I can check my factor of safety. I have a minimum factor of safety of 7, way above what I wanted to, way above my needs. So I can go in here and maybe make some more optimizing changes or remove some more material because I've used a stronger material now for these parts. So a great way to optimize your designs very quickly and see how things are going to react in the real world here. So once I've got that done, right, I've got my stresses calculated. I know my parts are going to work. They're good to go. I can release these things to manufacturing, right? But before I do that, I need to convey the information to manufacturing, whether that be an in-house machinist or if you're sending it out to be machined or a CNC operator, whoever's going to be machining these components or manufacturing them, I need to convey this information. Now, of course, the most common method to convey the information is a 2D drawing, which I'm sure everyone's familiar with. You make a drawing, right? Convey your dimensions, you print out a drawing or you send out a PDF or a drawing file to someone and they can manufacture the part. But what if I have a very complex part that is very hard to interpret from a 2D drawing? Of course, this is what a 2D drawing looks like. You know, everyone's very familiar with this. I've created a very simple 2D drawing. Now, in this case, this is a very simple part, so not that complex, but just for example's sake, if I jump back over to the actual part, if this was a very complex part, maybe I need to show this information in a different way other than a 2D drawing. So if you're looking toward the future, we have this great product called SolidWorks MBD, which gives a lot of options for creating 3D dimensions essentially. And I've already created a dimensioning scheme utilizing Dim Expert here. And if I show my dimensions, you can see that I've created these dimensions within a 3D space here. Now what I can do with this information is I can create specific 3D views for each view that I want to show, capturing a variety of dimensions in that view. So in this case, you can see I have a front view, and then I have a top view showcasing the thickness. And what's really cool about this is you can output these dimensions to either a PDF file or an eDrawings file, and then you can send that information along to your manufacturing team so they can get a better idea of what your part is going to look like in a 3D space with all the dimensions already spec'd out on that component in a 3D view. You can even attach a step 242 file to your 3D PDF so they can have the actual file itself. So if I publish this to 3D PDF, I can select the views that I want to bring in. I can specify a specific theme or a variety of different ways with my company information. I can have different views on there. I'll go ahead and publish this PDF just so we can see what it actually looks like within the PDF format. So now what you'll notice, if I click on that view from my views category down here, I actually have this 3D view in here, and I can rotate this view, I can zoom in, I can look at the data that is captured within this view, and I can flip views. I can make some custom notes in here. Maybe I need to make an update to a part. I can save it, send it back, and then make some changes that way. So a variety of ways we can convey this PMI or product manufacturing information to our manufacturing team, utilizing these features that show the part a little better than what you would see on just a 2D drawing, right? So now that I've communicated my part, I know what I need to get made. I need to get the parts back and make sure that they're actually what I requested be made, right? I need to inspect my parts. So I need to make sure that I have the correct dimensions spec'd out, the correct what is important, the key dimensions. And what allows us to do that is SolidWorks Inspection, which is our quality assurance essentially tool. So this will allow you to select critical dimensions. It will auto balloon a drawing. It's got a great feature for a standalone or an integrated add-in. And it also offers support for native drawings, PDFs, or TIFF files. So if you have someone sending you PDF files from outside, you can easily balloon those with SolidWorks Inspection. Now, once again, this is a very simple example, but imagine that you had a part with, 1,000 drawings on it, or I'm sorry, 1,000 dimensions on it, and you don't want to sit there and balloon every single dimension, right? What SolidWorks Inspection does is allow you to create a new inspection project, create a template, and then it will auto balloon your dimensions for you. You can easily specify part name and description and things like this directly from the drawing document itself, just by clicking on these and going through the information up here. Filling in all this information, how many parts in your lot, what type is this, what level, what's the acceptable quality limit here, where you want the ballooning to start, if you want it to auto balloon, multiple features in here we can select, and then what dimensions we want to include, if we want to include notes, hole callouts, and then we basically just hit the green check and it automatically balloons the drawing for me. And it creates this nice characteristic tree here that has each individual dimension laid out, what it is. So if I click on any of these dimensions, I can, maybe it's not an important dimension, I can deselect it and remove it from the drawing, and the numbering scheme will update for me. It also gives me whether or not I want it to be a reference dimension or a key dimension. So maybe this is really an important dimension to me. I can select that this is a key inspection dimension. It gives me an upper and lower limit based on the tolerances that I had spec'd when I created the project, letting me know right away that my upper and lower limit is. So multiple things that we can do with SolidWorks inspection. Also wanted to note that this is just the add-in for within SolidWorks. The inspection standalone is a great tool as well because it allows you to import CMM data. You can utilize a digital caliper with that tool. You can create custom Excel templates that are color coordinated to show dimensions either in spec or out of spec that can be filled in by your QA department. So lots of great features with inspection to really simplify this process with drawings. So once we've got all that done, right, we need to display our product. And how are we going to do that? We're going to do that with SolidWorks Visualize, our new rendering software that's really fantastic for creating very realistic designs to showcase the product. You can create marketing content in parallel with your design. It allows you to design in a truly photographic environment, present your designs to a customer with style, and you can even produce interactive content to aid in purchasing decisions, such as a turntable effect that will automatically rotate your designs, or an animation box that runs around your design to really showcase a 360 view of that design, or multiple other types of animations. We can have different configurations if you want to look at different surface finishes or colors on your design, and different backgrounds, lighting options. So really quickly, I created this mountain view of my mountain scooter in a real world looking environment with some lighting options and some shading. Snapped it to the floor, and this is what I came up with in only a few minutes, just to show you kind of how simple it is to create and showcase something. Now on a much more advanced scale, you might get an output of something like this that was done by one of our Visualize professionals. That really probably took some time on this to get the look, but you know, it really showcased the design and looks pretty fantastic, right? Another thing I want to point out was some of our SolidWorks free tools that can aid in the manufacturing process. The two main ones here that I wanted to look at were eDrawings and 3D Content Central. So if you don't know about eDrawings, it's a free tool that allows you to visualize your components. This is a great tool because it can work in conjunction with MBD, where you can maybe have some computers on your manufacturing floor that have eDrawings, so they're not taking up a SolidWorks seat. You can publish that manufacturing information directly from SolidWorks into an eDrawings file and then send it out to your manufacturing team so they can look directly at the file in 3D with all the dimensions and information and see everything in a real world 3D space. You can also use this great tool for maybe presentations or showcasing a design to upper management or something of that nature, where you just want to have an eDrawings file that you can output to a computer that also maybe not have SolidWorks on it. Another really great one that I think a lot of people forget about is 3D Content Central. So save yourself some time and download some pre-existing vendor and user CAD files by utilizing 3D Content Central. And that can be accessed through 3dcontentcentral.com. And there's over 1.6 million CAD users on this site already, and it's still growing. For instance, if I wanted to replace my shock absorber component on my mountain scooter, I can just go into 3D Content Central, find a shock, that's already pre-existing. I wanted to change it from a hydraulic to a spring shock. I came across this spring shock that I might be able to use. Once again, it gives you this nice 3D window powered by eDrawings. You can do multiple things in here like measure. You can look at a section view of your component to see what's actually inside it. And then it gives you all the manufacturing information. You can have different configurations to download. And then once you download it, it gives you your SolidWorks component. You can save that directly into your PDM database and implement it into your design. So save yourself some time by just downloading the files or the assemblies or the parts, opposed to designing things from scratch, right? So let's do a quick knowledge test to see if anyone is paying attention. What SolidWorks product would you use to reduce or eliminate 2D drawings from your design process? Let me go ahead and launch this poll. See if anyone's still awake. Give a couple seconds to vote on this, and then we'll wrap things up. All right, cool. Looks like mostly everyone voted. I'm going to go ahead and close this poll. So if you said MBD, you are 100% correct. So great job. MBD is the product we talked about, stands for model-based definition, where you can utilize the 3D realm to dimension your designs or your parts and save on those 2D drawings. So it's designed to eliminate or reduce 2D drawings. So great job if you said MBD. So some of the key benefits of all these products, right? We have a ton of different products. Can be very confusing on what product you need for what. But the key thing here is all these products work in unison directly within SolidWorks, with the exception of Visualize, which is a standalone product, and SolidWorks Inspection, which is partially standalone but also has an add-in. But they still all work together directly with native SolidWorks files, of course. Everything can be used in parallel to shorten your design and manufacturing process, which is one of the main goals I was getting at. You can bring your products to market much faster by implementing a variety of these SolidWorks tools into your toolbox. And of course, the big one that everyone's always concerned with, hopefully this will allow you to save a lot of time and money, right? By utilizing more tools that can really help get to production faster. So I want to thank you guys for taking some time out of your Wednesday to hang out with me. Thanks for attending, and think about how the suite of SolidWorks products can benefit any of your upcoming projects. If you have any questions about anything, feel free to give me a call or email, jspaniel@decide-solutions.com. I will hang out for a few minutes if anyone has any further questions. Thanks and have a great day.